But we're going to be doing intro to Git today. So my assumption here is that at least some of you have maybe never used Git or have only used Git in a very formulaic way and have not really thought very much about Git. So we're going to start with some basics. We're going to start by just configuring Git together, which honestly will probably take the first half hour of this session. That is just a reality of Git, unfortunately. But before I do any of this, I'm going to share my screen and make sure that we can all see it. Give me 1 second. Okay, Zoom, hopefully you can see my screen now. And we're going to hear the TV for just a second. Apologies. Oh, maybe not. Oh, it's not. Oh, there we go. Okay. Okay, so the hub is back, first of all. If you didn't see that announcement, we've got access to the hub again. For those of you on Zoom, feel free to put questions in the Slack channel, but I won't really be able to watch the channel while I'm presenting here. So also feel free to just shout out. We can hear you through the owl. So if you have questions, feel free to interrupt me. Same with everyone here in the room. I'm happy to answer questions. Okay, so I'm going to be doing this tutorial on the hub here, and I'm just going to go ahead and go to my home directory, and let me start from a slightly more common space. If you've just connected to the hub, you see something like this, and we're going to start by going to the terminal under this other category. So we'll launch a terminal here. We're going to be talking about the Git command line today. And we're going to be talking about the command line because it's a good way to kind of start understanding Git and to understand it from kind of a very basic perspective. There are lots of tools that exist these days that are different than the command line that sometimes can really help you understand what's going on. I have colleagues who really like a tool called Git Kraken. There's also Git Desktop. One of the advantages of these tools is that they let you kind of visualize what's happening a little differently. And so if you find the way that we go through this very unintuitive, I might suggest trying one of those tools. But we don't have those installed on the hub or anything like that. So we're just going to be using the command line today. Okay, give me 1 second to hide all these Zoom things. Okay. Okay, so just as a really quick introduction, Git is this kind of vast tool. It is one of the most complicated pieces of software we use in this course. And part of the reason that Git is so big and complicated is because it was designed for great big organizations like Google to be able to manage all of their code for all of their products together and to work on them together at the same time without causing issues. So most of you probably weren't programming back in the 90s, but I was programming in the 90s, and there was this very common problem where you would be working on a project with someone, and you would both have copies of the code, and I'd be over here editing the code, and I would change some things, and my colleague would edit the code and change some things, and then I would copy my code back up to our server or whatever, and I would just blow everything they'd done away because I just copied the whole code base with my changes, and I lost their changes. Or similarly, we could just pass it back and forth a bunch, but then I can't work on it except when I know that they're not working on it. And this is a real problem. And fortunately, Git has solved this problem at this point, if you're using Git, you pretty much don't have this problem anymore. You have different problems. You have problems where you don't understand what Git is telling you, or you don't understand what Git's trying to do. But Git itself is solving most of these problems behind the scenes. And the problems we have with Git, like for example, I try to do something and it gives me some complicated error about a merge issue. What that's telling me is that I'm about to blow away my colleague's changes, and it's stopping me from doing it. And so Git is kind of this layer on top of shared coding and shared programming that prevents us from doing anything really awful, first of all, and that enables us to work together very seamlessly. So in a minute here, I'm going to start actually using Git, but this is just kind of a big picture explanation. One of the things I'll just say up front is don't be afraid of Git. It is very careful not to delete things on accident. So a lot of people I know are really worried to use Git every time they want to use a Git command. They're a little worried they're going to destroy everything. That's just generally not the case with Git. Git will almost always preserve stuff. So even if you use the command like git rm to remove a file, that file's not gone. That file's still in your history, and you can get it back with the command line. Um, if you are about to run a command that would actually delete a bunch of stuff out of your Git repository, Git will not let you do that without giving you some kind of warning. So you're just in general, don't be too afraid of using Git. It's very powerful. It can feel very complex because it can handle all these things that we don't necessarily need in small projects. But ultimately, it's there as kind of a safeguard to prevent you from making mistakes in shared coding. Okay. That's a very kind of broad motivation as to why we want Git, but let's actually start using it now. And as we go, I'll try to explain a little more about why it's useful and why certain features exist. So for starters, let's just go to the website. If you go to github.com, which is where I am here, I'm already logged in on my account. If you are not logged in, please log in now. And I know you all have GitHub usernames because you sent them to me. So go ahead and log into your GitHub account. Once you're logged in, if you're just at the, you don't have to be at the splash page here, the github.com page, but once you're logged in, you should see something kind of like this. You should see a toolbar up here with some of these icons. This is my picture, but yours might be some like ASCII art character or something. You'll notice our attempts to fix the Jupyter Hub here in my feed. So a lot of the stuff we're going to talk about, we can do on the GitHub webpage. Just to kind of give you a sense of the difference between Git and GitHub, GitHub is a Git server. Git is a tool and a protocol for sharing code and synchronizing it with the server. So some of you may have Git accounts on like your university Git server, for example. Some of you may have something like a github.uminnesota.com or whatever, something like that. Those are like GitHub. They're not GitHub. They're your university's own server that does the same job. GitHub is obviously the most commonly used server. It's largely free for open source and public projects anyway. And it's just generally a great resource for sharing code. Okay, once you're logged in, what we're going to do first is we're going to make a new repository. A repository in Git is just sort of a place where we can put a bunch of files, code files, and share them and work on them together. So to start off with, we're just going to go ahead and create a new repository, and we can do that by going up to this plus button in the upper right. From this point on, I'm going to just follow along with me. I mean, you don't have to, it's up to you, but the idea here is that you'll follow along and kind of code with me. So go ahead and select new repository. And we get this create a new repository page. I'm going to make a repository called recipes. What we're going to do today is we're going to work through an example set of Git operations in a repository called recipes, where we're going to share just some recipes that are in text. We're not going to do this in code because I don't want to worry about like running code and everything right now. I just want to worry about Git. And so we're going to be just editing text files, but code files are text files. So this is pretty much the same thing. This is just a simpler way or a simpler example. This description is just for our own information. So I'm just going to say this is a repository of recipes. We have some options down here. In particular, you can make your repository public where everyone can see it, or private where only you can see it. I think there's a limited number of private repositories you can have unless you're a paying member of GitHub. I think they limit you to 6 or something like that. But for this tutorial, we're just going to make it public. And we're just going to leave the rest of these alone for now. These are just options to like speed up if it'll automatically create a README file for you, or it'll automatically add a license or something like that. We're not going to worry about that right now and just click this create repository button. Okay, so we have now created a repository, but it's saying basically, look, there's nothing in this repository. Here's some instructions on checking this repository out locally. At this point, we're going to go over to our terminal. Okay, so we could go ahead and try to clone that repository, which is to say we can go connect to GitHub and copy, download whatever is in that repository and put it on our local computer, or our local hub in this case. But if we tried to do that, we would get an error saying, I can't authenticate you. I don't know who you are. So we need to tell Git who we are before we can do anything that talks to GitHub, really. This is where we're going to configure Git, and this is going to be many commands. I apologize that this is going to be probably at least 20 minutes of commands. This is something we're only going to have to do once. And you only have to do this once per computer or terminal or whatever you're using. So if you run all these commands in the Jupyter Hub, they will be set and you won't have to run them again for the rest of this course, okay? You will have to run them again if you then try to run Git on your local computer, not in the hub, okay? But if you run these commands on your local computer, you'll have it configured and you won't have to do it again on your local computer. So again, this is going to take a little bit, but nonetheless, once we've done it, we won't have to do it again. Okay, I'm going to hide this panel just so we have a little more room, and I'm going to make this just a little bigger because I know some of you probably have trouble seeing that. Okay. First command, first of all, the command for Git is Git. Okay, so if we type like git dash version, we should see an error message saying you need to use dash dash version. Git dash dash version will give us something about the Git version. Okay, so Git's working. So the way the Git command works is typically you run Git space and then a subcommand of some kind. So the first subcommand we're going to run is the config command. That's to configure it. So we're going to say git config, and then we're going to say dash dash global. The reason we put this dash dash global is because Git lets you have different configurations for individual repositories that you've checked out, or to have a configuration for all of the repositories you checked out. And we want to configure, right now, we want to configure it for our user accounts so that any repository we're working in knows who we are and everything. So we're configuring the global settings. So we're just going to run git config dash dash global user.name space, and then in quotes, don't put your GitHub username, paradoxically enough. What we put here is just our full name. So for me, I'm going to put Noah, if I can spell it, Noah Benson. And again, you need to put that in quotes because otherwise it will not understand the space in your name. So I'm just going to run git config dash dash global user.name Noah Benson. The reason it wants to know our actual name here is because it uses that to sign commits. So like when you make a commit to someone's repository, it'll tell them that this was signed by me, Noah Benson, and that's why it wants to know your name. Okay, next. And you notice that didn't produce any output, and that's because Git generally doesn't produce output if it runs correctly, unless it needs to. Yeah, question. Is it important that
it fits the GitHub?
Okay, is it important that this name is like the same as the name you gave GitHub when you signed up? So to be perfectly honest, I don't know what happens if you put a different name here because I've never done it. But I would say you're mostly shooting yourself in the foot if you put a different name here. You'll just confuse people who look at your commits.
Do you know if it allows for special characters?
Does it allow for special characters? That's a great question. I have no idea. I would guess that it does. My guess is as long as you're using UTF-8, you'll be fine. But that's not something I've tested. I'm pretty sure your GitHub username cannot have special characters, but your name probably can. That would be my guess. Okay. Other questions? All right. Next, we're going to say git config dash dash global user.email. And once again, in quotes, we're going to put the email address you use to sign up for GitHub. So for me, that happens to be n@nben.net. But obviously, you should put your email address there. Okay. Next, we want to say git config dash dash global init.default branch main. Okay, so this is a little arcane. What's going on here is a combination of things. When we created that repository a second ago, we made a recipes repository. We made a repository that is empty. It has one branch. We'll talk about what a branch is exactly in a little bit, but a branch is basically like parallel copies of a repository that you can be working on simultaneously. By default, you get just a single branch called main. Now, the reason we have this init.default branch option is because 5 to 10 years ago, the default branch's name was master, and they switched to calling it main sometime around 5 to 10 years ago. And depending on what Git server you're on or what version of the Git command line you're using, it may not actually use, it may still be using master as the main, and that can cause confusion. So we're just configuring it here to say explicitly we're using main. That's what GitHub does these days. So default branch. And I think, okay, that's not all we're going to do, but I think that's all the git config lines we have to run. So we're going to say git config dash dash list just to check. And you can ignore this credential HTTPS thing up here. In fact, yours may look a little bit different than mine because I've configured this ahead of time, but you should at least see the user.name, user.email, and the default branch when you run this git config dash dash list. Okay. You notice, I'll just mention this. There's this core.editor setting. If you happen to like VI or Emacs, and if you know what those are and you want to use them, you can go ahead and run git config dash dash global core.editor, and then you can put Emacs or VI or whatever your preferred tool is. Make sure that we have it installed on the hub. So if you want to use VI, make sure VI works. But regardless, just FYI, you can put that there. If you don't know what Emacs or VI are, if that sounds like nothing to you, what you want to put here is git config dash dash global core.editor nano. Nano is, and I'm going to use Nano for this tutorial. Nano is a very basic editor, text editor that we can use in the terminal, and we'll use it for this session. But if you prefer Emacs or whatever, use Emacs or VI. Okay. Questions so far, or anyone getting errors or anything like that? Okay, good. All right, so we have done a little bit of configuration, but so far we haven't done anything that would let Git know that we are who we say we are. We've just told it who we say we are. So what we need to do next is come up with a way that we can authenticate with Git securely. So the way this is going to work is we're going to create what's called an SSH key, and I'm going to give you a really fast, big picture explanation of modern cryptography on the internet. The basic idea behind most modern cryptography is that there are these algorithms that let you come up with these really big prime numbers, and then you can multiply them together and come up with a really big number that has exactly two primes as factors, right? Why that matters, don't worry about it. It just turns out that it's easy to generate those large numbers, but very, very hard to take one of those numbers and figure out what the prime factors are. In fact, if I give you one of these really big numbers, it would take you like the age of the universe to figure out what the prime factors are. Why does this matter? Well, the way modern cryptography works is we do some really fancy math on these very large prime numbers, and we can treat the product of the primes as something like a public key. I can publish that to the world. I can tell you what my public key is, that is the product of the primes. And because it's so hard to factor those primes, that product of primes, it's almost impossible for you to figure out what the two primes that went into that number are. And so essentially, I have these this private key, which is these two prime numbers, and you have this public key, which is like their product. I'm simplifying a little bit here, but this is the basic idea. And you can, and there's some fancy math that will let you take any message and the public key and encrypt it into a different message, where the only way to decrypt it is to have the two prime numbers that I have. So essentially, I publish this public key to the world. Anyone can take that public key and encrypt a message so that the only person who can decrypt it is me. Simultaneously, I can take my private key and I can create a message where anyone with the public key can decrypt it, but the only person who could possibly have written that message is the person who has the private key. So it allows us to basically exchange messages where I can prove who I am, and you can read anything that I send out that's encrypted, you can send me encrypted messages and I'm the only one who can read them. And once we have that protocol, I can give you a public key and you can give me a public key, and then we can talk and nobody can read our messages except for each other. All of this is based on the fact that that factoring really large prime numbers is really hard and takes forever. But if this is interesting to you, you should go read about cryptography. It's really cool, but also very arcane. Regardless, what we're going to do here, oh no. Oh, shoot, okay. What we're going to do here is generate one of these public-private key pairs. And then we're going to take the public key and we're going to give it to GitHub and tell GitHub that that's our public key so that when we talk to it, we can encode things with the private key and GitHub will know it's us. Questions about that? It's not really important that you understand this in detail. I'm just kind of trying to provide context. Okay. So this is going to take a few commands that are a little weird. The first thing we're going to run, ssh-keygen space dash capital C, and then in quotes our email address. And you should use the email address you used for GitHub. Space dash T, lowercase t, ed 25519. You can tell I've given this tutorial a lot of times because I didn't have to look that up. Okay, when we run this, it's going to ask us some questions. The first thing it's going to say is, where do you want to save this key? And it's offering to save it in this .ssh directory in our home directory. That is perfectly fine, so you're just going to push enter. Now, in my case, it says I've already got one of these keys because I did this earlier because I've been using GitHub on the hub. It probably will not ask this question for you. What does it ask? What is the next question? Password? Password? Okay. So paradoxically, you want to push enter, don't enter a password. The reason is because you're the only one with access to this directory where it's going to save this key. So it's already safe. And if you put in a password, then you're going to have to type a password every time you run Git. So the whole point here is that you don't want to type a password every time. You just want to be able to authenticate automatically. So when it asks for the password, just push enter. It'll ask you to repeat the password, just push enter again. Okay, I'm going to say no because I don't want to regenerate my key. Well, I'll just regenerate it. I think that'll be easier. Okay, so I'm going to say just push enter and just push enter. Okay, and then it prints out this little ASCII art thing. This ASCII art should be unique. Like, hopefully you didn't get the same ASCII art I did. This is some signature of the public key that was generated in some way. Okay, so what this did is create this two files. If you type ls space tilde slash dot ssh to look at that directory where it put the key, you should see at least these two files. Whether you have these files, I don't know. But these two files contain the private key and the public key. So the public key is the one that ends in .pub. This public key file is perfectly safe to distribute to anyone. Like I said, it's a public key. That's the whole point. So what we're going to do is we're going to print the contents of that file to the screen. We can do that with the command cat, which is short for concatenate. So we're going to say cat tilde space dot ssh slash id underscore ed 25519 dot pub. Make sure that you have the dot pub at the end when you run this. You should see something like this. It should be about one line. It shouldn't be any longer than this, really. And what we're going to do is we're just going to highlight this whole thing, everything starting from the SSH hyphen to the email address at the end. I'm going to just right-click and copy this. Okay, so I've now copied my public key. And at this point, I'm going to go back to github.com. So I'm going to leave this on the screen for just a minute in case anyone's still typing. Actually, can I? Yeah, okay, well, I'll leave it over here. Okay, over here, I'm in GitHub. And I'm going to click on my icon in the upper right. And depending on how, if you're not in split view, you may not get quite this exact interface, but you'll get a drop-down menu. And we want to go to settings, the gear icon here. So just again, to show what I did, go to your to github.com, click on your icon in the upper right, and go down to the gear settings icon. Yeah, so it should look something like this. And if you scroll down on this left-hand menu, there will be an entry called SSH and GPG keys. So this is in the settings. But in the settings, there should be an SSH and GPG keys on the left. If you're having trouble finding that, you can just copy this address here, github.com/settings/keys. If you just go to this address, that'll work too. But basically, you want to get to this SSH keys page. And there's a big green button that says new SSH key. Go ahead and click that. And then my suggestion here is to have this be something like NeuroHackademy in the title. So this title is just for your information. The title is not relevant to GitHub. It's just something so you can remember what key this is. And then you want to come down to the key and you want to just paste the line that we copied from the terminal. So this line here is exactly the same as this line that was printed out over here. And then you can just click the Add SSH key. And you should be able to see it down here. I've now got a new SSH key here. And if you're able to do that and you see the NeuroHackademy key listed in this list, you're set. Is anyone having trouble getting that all done? Okay. I needed you to like log in, basically. Yeah, so if it asks you to log in, that's just because it doesn't want arbitrary people adding, like it doesn't want someone to come up to your laptop and while you weren't looking and add a key or something. So it often will ask you to confirm your password if you haven't logged in the last couple of minutes. Okay, so I'm gonna close this real quick. Would you mind helping could you raise your hand again, who is having trouble? Same thing? Okay, so no issue there. Awesome. Okay, anyone else having trouble getting this NeuroHackademy key to show up?
Possibly go a little bit. I felt a little bit.
Yeah, so did you need to see this part?
Yeah, how do we create the key?
So it's this weird command here, ssh-keygen -C and then your email address and then -TED 25519. So let me, just because this command is a little bit weird, I'm going to real quick paste it into the Slack channel here. If I can find it, Benson intro git. Okay. So if anyone's working on this command, it's in the Git channel now. Okay, I'm going to close out this side view here of the Git.
Sorry, can I ask you something?
Sorry, say that again?
Can I ask you something? Because I lost a
Yeah.
bit. Okay,
Sure.
so like I have just generated the key, but I lost the part that when you copy it, like in the GitHub.
Yeah. So sorry, you got it. Did you get it printed out and copied in the terminal and you just need to get it over to GitHub?
Yeah.
Okay, so go to github.com/settings. Whoops, I typed that wrong. Settings/keys.
Okay.
And you should see something like this. And there's this big green new SSH key button. So you paste the key into this, except that's not my key, but you paste the key into this big box here, and then just give it a name like NeuroHackademy and click the Add SSH key button.
Okay. I don't see like the key type, the authentication key that you have there.
Yeah, so if you don't see an option here, don't worry about it. It should be fine. I'm a little surprised you don't see like an option here, but if it's not giving you an option, I think it should default to an authentication key.
Okay. Like so, I just when I go to the settings and the key the keys, I just tap deploy key, right? Or no?
So okay, let me put this link in the Slack as well.
Okay.
So if you just click to that link, it should take you right to this page.
Okay. You type it in the announcements. You put the link.
Oh, my mistake. Did I?
I don't know.
No, I put it in the Benson intro Git channel. So the channel for this session is Benson intro Git. Yeah, intro to Git. So it's the link's in there.
Okay, thanks. Okay, now I have also the key type.
Okay, so yeah, so you should be able to paste your key here, give it a name. You don't need to change this key type, but just paste the key here and then add SSH key and you should be fine.
Okay, I got it, thanks.
Okay, great.
Now I got an option like verify via email, but okay. It asks
So,
me to verify it via
oh
my
yeah,
email.
yeah, so it'll often ask you to verify who you are, like log in again, basically, or authenticate again. That's normal. Once you authenticate, the key will be added, and you should be able to see it. Whoops,
Thanks.
no problem. Okay. Anyone else still having trouble? We want to get everyone past this step because this is like required to work with your team and such. So if you're having trouble getting this to work, give me some kind of sign. Okay. If you find that you're still having trouble later, we can always, in fact, during week 2, we often run what we call a Git clinic where you bring your broken Git to us and we'll help you fix it. So we're around to help fix this if it comes up again later. Okay. Oh, yes. Who's AP? Go ahead.
Yeah, I haven't managed to do that. So when I try to do when I try to check the key, it didn't find a directory SSH. And I've tried a number of things. I've tried to do that again, and I think it asked me if I should overwrite, and I overwritten it. I think maybe I should have I should have gone to the Jovian directory, but now it says saving key failed is a directory, so I don't know what to do.
Hold on a second. So you said when you typed ls tilde/dot ssh, it said that's not a directory. What did it say?
No, first of all, when I type ls ssh, it told me that it couldn't find any this directory. Yes, and then I tried again. Yeah.
Hold on, one step at a time here. So you type this command here, and it says it can't find the SSH directory.
I'll try that again.
So the thing I was going to say.
Now it does find it because I did ls. So I moved to Jovian. I was on home and I moved to Jovian. But then in the meantime, I tried to regenerate the key, and I think I might have done something wrong. I don't know. Now I do see everything. Yeah.
Okay. Yeah. If when you type
Hopefully it'll be
ls space tilde/dot ssh, you see these files, then you can follow the rest of the step. Like if these files exist, they're fine. You won't have run the command or anything. So you should be able to run this cat command to print out the key at this point.
I'll try. Thank you.
Okay. Cool. Okay. So at this point, I think most of us are on the same page. A couple people maybe still be having trouble. If you are having trouble, what I'm going to recommend at this point is go ahead and put it in the channel, the Benson Intro to Git channel, and Kelly is here and can help you out on the channel or can flag me if I need to explain something. Okay, so great. At this point, we have probably set up Git to work with GitHub. So we're going to go ahead and test that by cloning our repository. So what we're going to use here is a command git clone. And the clone command, the purpose of the clone command is to connect to a server like github.com and to find some repository there and make a copy of it locally on your computer. So this is how you basically get a repository from GitHub onto your computer here. So we have to give it the address of the repository, and we do that by using this format, git@github.com:. You always put that for a repository on github.com. Doesn't matter. Our username is not Git, but that's okay. We still always put git@github.com:. And then we put the actual username. So for me, this is Noah Benson. For you, it's your GitHub username. Although if you use my name, it will work. You just won't have permission to edit the repository because it's my repository. But you should put your GitHub username here instead of mine. And then recipes. That's the repository name. So every repository has a username and then a name. So repositories are typically referred to as username/repository name. So this is basically git@github.com: username/repository name. Okay, I'm going to push enter. And you see it says cloning into recipes, and then you appear to have cloned an empty repository. Okay, so that's fine. We knew that repository was empty. We just made it. But if I type ls now, there's all the stuff I had in here before, but there's now a directory called recipes. And if I cd into recipes, it's empty. It's an empty directory. That shouldn't surprise us because the repository is empty. But if I type ls space -a, which is list everything, even hidden files, you can see that there's this directory here called .git. So in Unix and Linux, file names and directories that start with a dot are always hidden by default. So same with like if I do ls of tilde, you don't see that .ssh directory, but if I say ls-a of tilde, you can see that there's a bunch of stuff, including this .ssh directory. And pretty much all of these files that start with a dot are hidden by default. So the same thing is going on here in this Git repository. There's this hidden directory called .git. And this directory contains all the information Git needs to keep track of that we don't want to think about when we're actually working on the repository. So there's stuff in this .git directory that says whose repository this is and what server we're connecting to, and not just that, but things that are part of the repository that we're not currently working on. I'll talk about that a little bit more in a minute. Okay, so let's go ahead and start actually working in the repository. Right now it's empty, but this is, oh yeah.
In the chat, a lot of people are getting the.
Oh, are they getting a fingerprint?
Yeah.
Sorry, I forgot about this. I forgot about this because I already did it. So the first time you connect to, okay, going back to cryptography for just a second. One of the problems with the public key, private key system is that when I connect to github.com and say, hey, GitHub, I want to send you a key, a public key, can you prove who you are? They will send you back their public key, but you don't have any way of knowing that that's them per se, and not someone who's like cut the phone wire in the middle of you and is like pretending to be github.com. That's why it's asking you that question, is if you're really worried about security and you think someone might be listening in and doing a man-in-the-middle attack, you might want to go verify that this is the correct key. I promise you it's the correct key. You can just say yes. You may have to type out YES. I don't think you can just type Y, but go ahead and say yes to that prompt and it should be fine. Yeah. Is it possible that you'd put a slash instead of a colon here? No, that's not it. Would you go look? Yeah. The other thing I would say is that you might have a typo in either your username or the repository name, or okay. Anyone else get any other weird errors? Okay. Once you say yes, were you able to clone an empty repository? Okay. Okay. Good. So go ahead and cd into that repository, and I think we should be good to go from there. All right. So the first thing we want to do here is add something to this repository. So I'm just going to open up a text file. I'm going to say nano. Nano is the text editor. Feel free to use your own favorite text editor if you have one. But I'm going to say nano guacamole.txt. Okay, this is going to be my guacamole recipe. Okay, when you start nano, you probably get something that looks a little bit like this. This is just a very simple text editor interface. You can use the arrow keys to navigate. Down here at the bottom, it's telling you kind of like shortcut keys that you can use, and these carets, these up arrow things, stand for the control key. So if we want to exit, we push Control X, for example. Okay, so this is my guacamole recipe. I'm going to say ingredients, and the first ingredient is avocados, onions, cilantro, salt. Instructions. Mixed together. Okay, this isn't the best recipe, but that's fine. I'm gonna leave it at this. I'm gonna push Control O, which is short for write out the file. And it gives us this little prompt, file name to write, guacamole.txt. I'm just gonna push enter because that's correct. And then it tells me it wrote 9 lines. And then I'm going to push Control X to exit out of here. Yeah. Gotta do that again? Yeah. Okay, so nano guacamole.txt. So then once you're in here, you write out your recipe. Once you've got it written, so right here, this tells us that if we want to write out the file, we push Control O. So I push Control and O, and it says, what file name do you want to give it? Guacamole.txt is fine, so I just push Enter. And then to exit, it's Control X here, so I just push Control X, and I'm back out. Okay. Yeah.
Maybe a stupid question, but like, do we have to in Git, like, what is the default, like, permissions? Like, do you ever have to use Studio or like?
Okay.
Yeah, like.
Good question. So the question is, in Git, what are the default permissions? Do you have to use like the super user command or sudo command or anything? No, Git is just about, it's all going to run as you. And the idea here is that the Git program can authenticate to github.com and it will talk to github.com as you. But all of the Git data is going to be stored in this directory here that we've just checked out in your local home directory. It's not like you might be comparing it to Docker, where Docker like stores a whole bunch of stuff in some secret place that you can't see. It's not like that. Docker is a little bit based on Git, but yeah, they're different. Okay. Okay, so we made this file. If I just type ls, I can see the file here. If I type cat guacamole.txt, we can see the contents. So we've got a file. Now, we haven't told Git about this file, but there's a command we can run. Suppose I leave and I come back and I don't remember if I've done anything with this file. There's a command git status, which just asks Git to tell us what's the current status of the repository. This is what it outputs. It says, we're on the main branch. We haven't made any commits. We'll talk about what a commit is in a minute. But there's this untracked file named guacamole.txt. So basically, it looked at the directory and said, you've made a text file that I don't know anything about. And it's listing it here. So if we want to tell Git about this file, we need to use a command called git add. And that's basically telling Git we want to add this to an upcoming commit. So I'm going to say git add guacamole.txt. It doesn't print any output, and that's because for most commands, if they work and they don't need output, it just won't print anything. Okay, so I've added guacamole.txt, whatever that means. I can now type git status, and it says still no commits yet, but there are changes to be committed, a new file, guacamole.txt. Okay, some of you are going to have questions about why we're doing things this way in a minute, but I will explain. We're now going to say git commit, and we'll just type git commit by itself. And it should open up Nano when you type that. Now, if you set your editor to something else, it'll open up that other editor. But for me, it's going to open up Nano. And you notice it's got this message, please enter the commit message for your changes. Okay, let me just back up and tell you what's going on. When we typed git add and then guacamole.txt, what we told Git is that we're preparing a commit. A commit is just a change to the repository. So running git add does not actually change anything in the repository. It's just telling Git that we're getting ready to change the repository. When we type git commit, we're saying take all those things we've added and actually make them a permanent part of the repository. And so it's asking us for a message because it wants to know what we've changed. Like, what did we do? We want to give whoever comes along later and looks at the repository some information about what we're doing. And usually these messages are like, oh, I fixed this bug that was causing whatever, and I did it by editing these files or something like that. But here we're just adding a new recipe. So I'm just going to write a very simple message that says, adding a recipe for guacamole. Again, I'm going to push Control O to write out this file. And you notice it gives us this weird commit edit message file. Don't worry about that. Just push Enter. It's the right file name. And then we can push Control X once we've saved it. Okay, so here's the git commit command I ran, and it's giving us a little bit of information here saying we've got one file that's been changed. 9 lines are inserted for this guacamole.txt. Yeah. I can't hear you.
While you were describing this cool stuff, I missed out on it because I was still stuck.
Okay.
back up.
Yeah, I can go back and repeat. Will that help you?
Sorry, yeah. Well,
Okay, so, all right, so, did you edit, do you have a guacamole.txt file?
Yeah.
Okay, so if you run git status, git space status, it'll tell you something like this file is not yet tracked, guacamole.txt. And what you want to do is type git add guacamole.txt. And then once you run, and you can run that command, it should print nothing. It should just basically have no output. Now for me, I'm not going to run this again because I already ran it, but you can just run git add guacamole.txt. And then once you've run that, you can run git commit. And git commit will open up an editor where you can type a commit message, and you just type any commit message like adding a guacamole recipe. Yeah.
Get add guacamole text says, so do I need to CD somewhere? And right now,
You should have, yeah, you should have CD'd into recipes when we first made the repository. Okay, Kelly, would you mind helping out? I think he's just in the wrong place. Okay, you have a question? So?
I'm here in git commit. I pressed enter, it didn't open up Nano, but I saw it's the same message that you had. It just didn't have like the Nano.
Okay, did it look kind of like this with a bunch of tildes?
Has like hashtags. And yeah, it's until these two, yeah.
Yeah, okay, so that means you're in VI. If you end up in a screen where you see a bunch of tildes down near the bottom, that means you're in VI instead of Nano. VI is a little tricky. To get out of VI, you need to push colon, Q, exclamation mark, enter.
That was my next, try next.
Okay, if you got into Nano, to VI and you didn't want to get into VI, then you need to run git config -- global core.editor nano, like that.
And then Nano, and then git commit again.
Yeah, and then run the git commit again.
Perfect, thank you.
Okay, yeah.
That's something and go.
What happens if you add and you don't commit afterwards? Nothing. But the repository hasn't changed in that situation.
Things that.
Okay, yeah, great question. What if you add multiple things and then commit? So actually, this is a very common point of confusion. Why do you have to add and then commit? Why not just commit? And that's a really good question. The reason is because most of the time when we're using Git, we're working on a big software project that has lots of files. And I'm coming along to add some feature. I'm gonna add a new feature that runs this analysis. And that means I need to write a new file, but I also need to edit like 3 or 4 other files, right? Because those files need to know about this new feature. And if I write the new file, but I don't edit those other files, and then I commit that new file, you can come along and pull the code and it's broken because I haven't edited those other files. Those files are really part of the same change as the new file. So you want to be able to package a set of changes to a bunch of files all together as one commit in order to make sure that people don't pull code that's like half finished or something like that. So depending on how you use it, this is more or less important. If you're the only one using the repository and you're the only one who can see it, then it really doesn't matter that much if you check things in like a really coherent way. If you're sharing a repository with lots of different people, you don't want them to accidentally pull half-completed code because then they might start editing things and then it could get very complicated. Yeah, Ruben, go ahead.
When you did git commit, did you make any changes inside the file that opened with Nano? I didn't see.
Yes, so when I did git commit, I typed a line at the very top that just said, adding a recipe for guacamole. If you don't make any changes to that file in the git commit, it will say something like empty commit message aborting. So you're not allowed to commit a change with no message. Although if you go look at lots of repositories, you will find lots of messages, commit messages that just are IDK, standing for I don't know what I did. That people are not necessarily all that good at writing commit messages, but my recommendation, especially officially, is to write really nice commit messages that say exactly what you did. It does require a commit message. It doesn't require a detailed one. It's also kind of customary to write like a one line at the top, like your first line of your commit message is just big picture, what did I do? And then to skip a line and write a bunch more detail if you've got a complicated commit. Okay. We still got some time. Okay. So at this point, we have committed something to our repository. So if we type git status now, it says we're still on branch main. It's giving us this message about set upstream. We'll get to that in a second. But basically it's saying nothing to commit working tree clean. So it seems like everything's up to date sort of. So, whoops, let me hide this. Okay, so let's go back over to github.com. I'm going to go back to github.com. I'm going to go to github.com, oops, /Noah Benson /recipes. So go ahead and go to your recipes repository. And looking at this, it still is telling me that I have an empty repository. So it seems like whatever I did, that commit didn't really work, or at least GitHub doesn't know about it. So what's going on here is that, just because we've committed something doesn't mean we've synchronized ourselves with the github.com server. What it means is we've added that change to our local Git repository. But if we want to tell github.com about it, we need to run another command, which is git push. And in this case, I think we need to run, I think we may need to run git push origin main, because this is the first time we're pushing. And we just need to tell it that we want to push up to the repository that we originally cloned from, and we want to push into the main branch. Okay. So now, from now on, we don't need to run origin main. We can just run git push because we've now told it where we're pushing to. But the first time we run it there, we want to run git push origin main. And it tells us, look, it's giving us all this information about what it's doing, mostly that it's writing stuff, and up to github.com, it's making a new branch. Okay, so now that I've run this git push command, I can go back over here, and if I just reload this page, I can now see that there's a file, guacamole.txt here. And if I click into this file, I can see my simple little recipe here. Okay, so it turns out that if you're logged into GitHub, you don't necessarily have to do all this on the command line. You can actually do a lot of this stuff in Git itself. So let's just do an example of that now. I'm here in the guacamole.txt file. If you're not here, again, go to your recipes repository, go to yours, not mine, but your recipe repository, and click on the guacamole.txt here, and you should be able to see the file. And then if you click this little pen over here, that's the edit this file button. So if I click on that, I actually get an editor on github.com where I can say, okay, we forgot lime. Mixed together, and I'll say mashed with fork. So here I'm making some edits on github.com to this repository, and I've got a big commit changes button. And when I click this button, it actually proposes that my commit message should be update guacamole.txt. Okay, that's fine with me. I can add more description here if I want, but I'm just going to go ahead and commit these changes. Okay, so now guacamole.txt includes our updates here on Git. All right, so if I go back over here, back to my terminal, and I cat guacamole, what do you think is going to happen? Yeah. Oh.
Can open the APP when I did the push.
When you ran git push origin main, it said cannot.
I cannot find the APP key file.
APP, oh, the app key file?
Yeah.
Were you using GitHub through some other means on the hub earlier?
Yeah.
Yeah, okay. I think what's going on is it's trying to authenticate with HTTPS, which is another way of authenticating that's a little more complicated. We can help you fix that later. I'll need to do some Googling to figure out how to fix that, sorry. A common theme of GitHub is that like I've said, it's a little complicated. So even those of us who use it all the time often have to go ask the language model how to fix things. Fortunately, the language models have gotten pretty good at understanding Git, so it's often pretty good at understanding your problem. But sorry, well, we can fix that in a little bit. Okay, So if I just run cat guacamole.txt, I don't see those changes from the website, right? And once again, the reason is that I haven't told Git to synchronize with github.com since we made those changes. So last time we ran git push, this time we're going to run git pull to pull everything down from the website. And it's going to print out a little bit of stuff here. It's actually telling us the changes it's making. It's saying we're changing 3 lines in guacamole.txt. I think I deleted a blank line at the end, which is why there's a red minus sign here, and the other 2 are like I inserted 2 lines. And now if I cat guacamole.txt, I see the new additions. Yeah.
File directory, specify like which file, can you only pull it, could you just pull and push one of the files of your directory, or do you always pull and push one?
Yeah, okay. So for everyone online, the question was, do you always pull and push everything? Can you pull and push individual files? So there's the answer is yes, you absolutely can pull and push individual files. It tends to be a little more complicated. This is a good point to transition a little bit and talk about what a commit actually is. And I will get back around to your question, but it will take a minute. So, at this point, I really wish I had an annotation tool, but I'll live without it. Okay. So when we make a commit in Git, Git does not ever store the state of the repository right now. There's nowhere in that .git directory that stores everything, all the data about Git, is there like a copy of the current state of the repository. Instead, what Git actually stores is whatever you've changed. So our first commit says, we added these lines to this file. And the next commit said, we added these 2 lines and deleted this blank line from the file. But it doesn't say, here's the whole file. It says, here's the changes. Every commit you make is like, is basically a change from some state to some new state. And you can kind of think of a repository as a stack of commits. So we start with nothing, we add a commit that makes a file, we add a commit that changes it, we add commits that make more files, etc. And essentially, if you start at the top of the repository and you follow the commits backwards, you can get to the very beginning of the repository. This is how Git is able to just, at any point, you can always say, go back to this date or go back to this commit or whatever, and Git can go back to exactly what the repository was like at that time. And this is true however old your repository is. So like I can still pull up repositories that I still work on and say, tell me what this was like in 2011. And it will do it, no problem. Now, one of the reasons Git is so robust to deletion is because when you delete something in Git, what you actually save is an edit that removes those things. If you just go back one more commit, that edit isn't there and the data is still there. So because you're saving this history of changes, you've got the whole history of all the edits always available. Okay, so Git organizes these things into files, but ultimately it thinks about everything as a commit behind the scenes. When you run git pull, it pulls all the commits that are new that it doesn't know about yet from GitHub, and it goes ahead and updates the current state of this directory to reflect the addition of all those commits. There's another command called git fetch, which pulls all those commits down, but doesn't update the directory. So if I were to say git fetch right now, and I had made a new change on my recipes repository, it would go ahead and pull down all those commits so that it knew about them, but it wouldn't actually update the status of the repository. So this directory would stay the same. And what you can then do is you can say git checkout and give it a particular file name, and it will check out the most recent version of that file from the repository. This is all a little bit more advanced usage, but the point is that there's a lot of fine-tuned control over exactly what you're looking at in Git and what the current state of the repository is. And let's just unpack that a little bit. If I type git log, it actually prints out a log of all of the history of all the commits in the repository. So here's the first commit where I said the commit message is that I'm adding a recipe for guacamole. And this is when it was made. And then this is the second commit, which I did on the website where I updated guacamole.txt. I can also say git log -- one line, and it'll make just a kind of more condensed version of it. So each of these commits or each of these lines is a commit. Okay, you notice how here it says head main, origin head. What this is telling us is that head is the current state of the repository. And if you think of the repository as a stack of commits, the head is just an arrow pointing to one of those commits, usually the one on the very top, right? So if I want to change this repository to be equivalent to a previous state, I can tell it, hey, update the head so that it's the previous commit or something like that. Okay, why am I telling you about this? Honestly, it's pretty rare that you want to change the head of your repository except for by adding and committing things. The reason I'm telling you is because this organization with commits allows Git to support branches very, very seamlessly. So Git branches are ways that you can have multiple copies of the repository at once. So let's just do this as an example. I'm going to say git checkout -b, which is for new branch. I'm going to what to call this repository. I'm going to call this just dev, the dev branch of the repository. So what I've done here is I've made a new branch called dev. So a lot of times people name branches dev for development, like they're working on a new feature. We're developing a new feature, so we call the branch dev. Why would we do this? Well, if I'm working on a piece of software, other people are using this software and they're using the main branch for themselves. That's kind of the current state of the software repository. If I want to add a new feature, it may take me a month or two to add a new feature, and I may commit changes while I'm adding that, and those changes may break the repository. But I want everyone who comes to the main branch to still be able to use the code while I'm developing on the development branch. Okay. When I run this git checkout -b, if I now type git log --one line, it's still the same because this is just a stack of commits in the repository. When I told it to make a new branch, all it did was it said, okay, we got a new branch and it's also pointing to the top of the commit stack. If I now make a new commit to this branch, it'll add the commit to the GitHub repository, and the dev branch will point to that commit, but the main branch will still point to the previous commit. So let's walk through that. If that didn't make sense, I'm hoping that once we see the example, it'll make a little more sense. So here we are in the dev branch right now, and we can tell we're in the dev branch because if we type git status, it'll say we're on branch dev. I'm just going to go ahead and open up a new file called shortbread.txt. Yeah.
If you change multiple files, but it shows changes for every single file.
Good question. So the question for those on Zoom is if you run git log after you've changed multiple files, will it show the changes for every file? Git log doesn't actually show you the changes in the files. It shows you the commits. So I'll just hold on. Just to show you real quick, there's actually a git diff command, which will show you the changes currently in your directory that haven't been committed yet. Right now, I have no changes that haven't been committed, so it's empty. But if you want to see differences in files, you can use the git diff command. I can show you an example of that in just a second. But the git log command, all this is showing you is commits. It says updated guacamole.txt because that was my commit message, not because it knows guacamole. Or it's telling us guacamole.txt was changed here. Does that make sense? Yeah, so every commit will show here, but you can have many files in one commit. So if you had multiple files in one commit, it would only have one commit message. But yeah, so just because this is kind of important, I just want to show you that if you go to github.com, there's this button here that says 2 commits. If you click this button, it's going to show you the whole commit history for this whole repository. And in this case, there's just 2 commits, these 2 that we've made. But if you want to see what was changed here, you can click this button here, and it says View Commit Details, and it will show you exactly what was changed. And if there's multiple files, it will show you all of them here. So it is very easy to see this. It's just a little easier on the website. Okay, back to where I was. So I'm going to say nano shortbread.txt. Okay, ingredients. Flour, sugar, butter, salt. That's pretty much all the ingredients you need for shortbread. Again, I'm going to have a pretty simple recipe. Mix and bake. Okay, I'm going to just go ahead and Control O to save this out. Shortbread.txt is fine, and then Control X to exit. Okay. If I run git status, it says, look, there's a shortbread.txt file that's not tracked. So I'm going to say git add shortbread.txt. And then once again, we need to do a git commit. Now this time I'm going to use this option -m. If you use this option -m, you can provide the commit message on the command line in quotes. So I'm going to say adding shortbread recipe. And when I do it this way, it won't bring up nano. It'll just use this commit message here. And that just saves me a step, basically. So there, I've committed it. And now I can go ahead and git push up to GitHub. Now, I think when I run git push, it's going to tell me that the development branch doesn't exist yet, and I need to tell it where. So it's basically saying the same thing. We're going to say git push origin dev. And now it's gone ahead and pushed. So here's the command.
Are you supposed to do git add after you?
Yeah, I ran that, although I did it pretty quickly. It's right here. Yeah. If you just have one file, by the way, you can go ahead and say git commit and then give it a file name, and it will do the add and the commit for you. But if you've got multiple files, you want to use git add. Okay. Did I go too fast? Do I need to back up for anyone here?
Sorry?
Yep.
Why did you did both git push and git push origin dev?
So when I ran git push, because this is a new branch, it basically said, hey, this branch doesn't exist on github.com. You need to tell me what branch to push to. And so it gave us this like kind of an error message. If you say git push origin dev, you're basically telling GitHub, I want to push to the original repository to the development branch, and then it knows where to push to. But from then on, from then on, we shouldn't have to do that. We should just be able to say git push. Okay, so if I now go back to github.com, I'm just going to go back to github.com/Noah Benson /recipes. Okay, so first of all, if you notice there's no shortbread.txt file here. And that's because we're looking at branch main. But if we click this little button here, this is the branch button, we now see that there's a main and a dev. So if we click over to the development branch, we see the shortbread.txt file. Okay, why are branches important? Because when you all are working on the projects, you're going to have a shared repository, and some of you are going to go work on something, and some of you are going to go work on something else. And you're going to want to work in different branches, because otherwise you're very likely to run into merge conflicts. We don't really have time to talk about merge conflicts in this session today. Merge conflicts occur when you've been editing code and someone else edits code and they check in the code and then you try to check in the code and they don't agree. So if we've both edited the same file or like the same line of the same file, and we're both trying to check our code in or push our code up to GitHub, we get a merge conflict. Merge conflicts are actually usually not a very big deal. You just need to go tell Git what you want the code to be like at the end of the conflict. And what I'll say is that if you run into these, and you probably will run into these over the next couple of weeks, if you run into these and you have trouble figuring them out, just come talk to us. We do this every year. Merge conflicts are very common. But the main purpose of branches is to try to avoid merge conflicts, or at least delay them until you finish whatever you're developing on and then are ready to merge the whole branch together. Okay, so there's just a couple things more things I want to show you guys before we run out of time here. One of them is that thing I just said, when you're ready to merge the whole branch together. So let's suppose we've been working on dev for a while. We've come up with new recipes. We're ready for dev to become main. You notice up here, there's this button that says compare and pull request. And then up here at the top, there's also this pull requests button. So this button won't always appear. This is kind of telling us that it thinks we might want to merge dev because we just made a change to it. But if we click on this pull request button up here, we can click this big new pull request button. So what a pull request is it's a way of sending a request to another branch or another repository and saying, hey, I've made a change and I think you might want it in your repository. One of the main reasons we use pull requests is because, for example, I'm using NiLearn or something like that. I'm using it in my analysis for my own research. I use it for a while and I realize there's like a bug somewhere, like a little bug somewhere in NiLearn, and I want to fix it and send it back to them. They don't know who not the people who run NiLearn don't know who I am, so they're not going to let me just edit their code on their repository. But I can make a fork. I can fork their repository, make a copy of their repository that's my own repository, and I can edit that repository freely. And then I can send them a pull request that says, hey, I think you want this change that I've added, but it's up to you to pull it into your repository from my repository. That's the basic idea of that's one of the main uses of a pull request is for like open source software development, for collaboration on open source software. In this case, we're doing a pull request across branches, and basically what we're saying is we're going to say, look, there's a little arrow here. I want to take dev and I want to merge it into main. And once I select that, it says, okay, here's the changes that are going to happen when you do that. And basically it's saying, look, you're going to have, main's going to get a shortbread.txt file with all these changes in it. So then I can go ahead and click create pull request. Oh, am I?
Where should the people click to get to this point?
Okay. Sorry, yeah. So if you go to github.com and then go to your recipes repository, there's a pull request tab up here. And this is all the pull, this is the tab for the pull requests for this recipes repository. You click there, and then you can click this new pull request button. And then you can for this thing up here is telling us what we're pull requesting from and to, and you can click this this one on the right and select dev, which is saying that we want to merge dev into the main branch. So we're going to take everything that's been added to dev and put it into main. Okay, cool. Okay, and then you can click this create pull request, which I just did over here. Once you click that create pull request button, you should have something like this where you can open a pull request. I think this title is fine. I'm just going to push the create pull request button. And now we have an open pull request. And we're getting this message that says there's no real conflicts here. If you're ready to merge it, you can push this button and merge it. Sometimes this will not say no conflicts. It'll say this is going to overwrite changes that you've made or something like that, and you have to resolve them. But in this case, this is a very simple pull request. There's nothing that's going to be lost when we do this. So I'm just going to push the merge pull request button and then confirm the merge down here. And pull request successfully merged and closed. So before I click that button, we had an open pull request, and you can see that by the one up here. But if we now click over here, we should have none. We have one closed pull request. If we go back to the repository root, just the repository page, we can now see that shortbread is in the main repository. So we merged that branch into the main repository, and there's still a dev repository, but it's now identical to the main repository. Okay, so my intuition is you'll be using branches to work on your projects next week, possibly this week. There's one more thing I want to show you here, and this is the easy way to work on repositories together. The harder way is for everyone to fork the same repository, work on it separately, and then pull request across repositories. But oftentimes what we actually want to do is just give our friends permission to work on our repositories. So for that, again, we're going to go to the repositories page, the repository page. So here I am at noahbenson/recipes. For you, it'll be your GitHub username/recipes. You can click this settings tab, and notice that this settings tab is settings for this repository. It's not my user settings, which is in this menu. We want to click this settings tab for the repository. And then the very first thing on this left-hand menu after general is collaborators. You can click on collaborators, and then you can add people, and you can just put in someone's GitHub username, and then they will have permission to work on your repository, to push and pull and make changes and commits and everything. So this is kind of this is generally how I would recommend working together next week. This is certainly the easiest way to do it. It does mean that someone else could, in theory, clobber your changes, but As we saw, Git doesn't really lose changes. So if you think someone clobbered your changes, chances are you can come to us and we can help you get them back. Okay, there's honestly so much more I'd like to go through, but we don't have time to go through everything. I want to show you maybe a couple more things. You had a question? Yeah. I believe that's right. Yeah. The permissions are for the specific repository. So let me just, I'm going to add Kelly here to my repository. And yeah, it sends her an invite. If she accepts this, she can push and pull and edit, like it's full rights for the repository. Okay. Okay, I'm gonna go back to the repository kind of main page again. Okay, so I showed you that there's this history thing. You can actually there's quite a bit more in this interface. You can use these buttons over here to browse the repository at that particular point in time. So for example, if I want to see what the repository was like right after we updated Guacamole, but before we did any of the rest of this, I can click this button over here, and it takes me to a version of the repository that was this is exactly what the repository was at that point in time. Whoops, didn't mean to click on that. Okay, so you notice there's this little hash code here, BC3F, whatever. And when we looked at this commit history, each commit had a little hash code, right? So there's a unique hash code attached to all the commits. And in fact, if I go back to the command line and I say git log one line, there's little commits over here. There's hash codes over here, and these are the same hash codes on the command line as there are over here in the history on Git. And that's because these hash codes are just unique identifiers for every commit, and Git and GitHub use them to track the commits, basically. Whoops. Okay. So if you want to go back to a different point in time in your repository, you can do that on the command line. And I'm just not sure that's something we want to do right now. So okay. Yeah, I don't think we're going to get into this. So if we had more time, I would show you how to rewind your repository. Generally speaking, you don't want to rewind your repository. It's usually a bad idea because other people who are working on it, if you rewind and then push, you will change the history of the repository. And in fact, Git will generally not let you do that unless you tell it, yes, I really know what I'm doing. This is what I want to do. It requires you to use like special options that tell it to force the change and stuff. Let me instead of that, let me just go over a couple other kind of useful things. So let's suppose, first of all, I'm going to git pull just to make sure everything is, sorry, I think I needed to say, I'm still on my mistake, git switch main. I want to go back to the main branch, and then I'm going to git pull. And it pulls down shortbread.txt. So sorry, I went through that kind of fast, but I wanted to go back to main. So the command to switch branches is git switch, and you can just say git switch main. And then when I ran git pull, it will pull everything from main. And I've now got a shortbread.txt file here. Now suppose I want to edit this. I'm going to say nano shortbread.txt, and I'm gonna fix my instructions here. So first of all, I'm going to say mix butter and sugar, add dry ingredients, bake at 350 Fahrenheit for 1 minute, something like that. Okay. I'm going to go ahead and write this file out, Control O, and then push Control X. So we mentioned this command earlier, but there's this git diff command. And when you run git diff, it shows you all of the differences between the current repository's state and what you have in this directory. So because I have not added or committed this change that I just made, it's showing me here that these are differences. Diff is actually a command. It's a basic command in Unix, and it will show you differences between files kind of like this. And that's all that's actually getting run here is it's running a diff command on the repository. What it's saying basically here is we're comparing shortbread.txt to itself. And these red lines that start with a minus are saying those are things we deleted out of the file since well, the last commit. And these green lines with the plus are saying those are lines we've added to the file since the last commit. Yeah.
So, and then the cryptic way of describing, I guess what you just said, so -5, 6 is subtracting lines 5 and 6 and plus. It's a comma, but really it's like 5 through 8 get added. I'm trying to understand that because that's.
Yeah. So, okay, so for people on Zoom, the question is essentially, what is this nonsense here at the top? I'll be perfectly honest, I've never really learned how to read these. I think you're probably right. I think it's something like lines 5 through 6, deleted lines 5 and 6, added lines 5 through 8. But I would need to go look that up. I'm honestly not sure. It is the format of the diff command. So if you want to find out, it's Google the diff command and it'll tell you how this works. Yeah. Yeah, there's a whole sequence of old Unix commands, diff and patch, that are designed for like, I've got a little change to some code. I need to go put it in like my library or something like that. And they work by telling you what's different, adding those differences into a file, that kind of stuff. And Git is built on top of those. Okay. At this point, yeah, if we had more time, I would have us all do an example of forking a repository. We really don't have time to do that. So instead of trying to cram that into 8 minutes, I'm just going to say, let's open the floor to questions. What questions do you have about Git? Doesn't need to be about these commands necessarily. It can be general questions about how to use it or why we use it or whatever. I'm happy to chat about it. Yeah.
The difference between a branch and a fork?
Yeah, great question. What's the difference between a branch and a fork? Okay, so branches are separate copies of the code of the repository within one repository. Forks are separate copies of the repository in different repositories. So for example, the NumPy repository exists in something like numpy/numpy. I think the username is numpy. So within numpy/numpy, the repository, there's a branch main and there's a branch for version 1 and a branch for version 2 and a branch for the development of version 3 and stuff like that. There's all these branches. They're all in the same repository though. And when you run git pull, it synchronizes every branch simultaneously. If I then go and fork numpy/numpy, it creates a whole new repository, Noah Benson/numpy, but that repository has exactly the same commits. They're all exactly the same with the same IDs and the same users and everything. So when we run something like a pull request, Git doesn't really care. I mean, it does, but it fundamentally, it's not that important whether it's between branches or between forks. What Git cares about is whether the history of commits matches this history of commits enough that it can merge them. So whether you're merging between forks or between branches, it's pretty much the same idea. Branches are just kind of more internal and in particular, you use branches when many people are working on different features or different features within one repository, but they all have permission to use that repository. And you use forks when you're getting a pull request or some kind of contribution from someone who doesn't have access to your repository, at least not to edit it. And you're basically letting them go work on it by themselves and then send you a pull request. Okay, did that answer the question? Yeah.
Yeah.
Mm-hmm. Yeah, so when you make a branch, it makes a branch that is an exact copy of the current state of the repository. And again, this is, if you think about the repository as a stack of commits, with the branches being pointers to particular commits. So essentially the main branch typically points to the top of whatever commit stack. And then when you make a dev branch, you're kind of making a separate track of commits that come out of there. And then when you merge them together, you're putting them over on top of the main branch and then updating the main branch pointer. Did that answer your question? Yeah, okay. Other questions? Yeah. Yeah, okay. So some of you may have noticed that over here when we did the pull request, after we did the pull request, it said something like pull request successful. Do you want to delete the branch or something like that? I don't remember exactly what it says. The reason it's doing that is because it's really common for people to basically take a like the main branch, be like, oh, we've got a bug. It's a little bug. I just need to fix it real quick. Rather than try to edit it in place where you might make things might make things worse, you just quickly make a branch that's like a bug fix branch. And then you play around with it until you're sure that branch is fixed. And then you merge it back into main so that you never accidentally merge a half-fixed branch. And so because that's such a common workflow, there's that option where as soon as you've merged back into main, if they see that your old branch is now identical to main, they'll say, oh, you probably want to delete this because you probably are done with this bug fix now. That's the reason that's there. Yeah. Other questions? Yeah.
On Jupyter, is there an easier way to connect to GitHub? Because I know that in previous versions of Jupyter or certain versions of Jupyter, there's like a widget there for GitHub.
So my okay, I totally believe you that there's a widget. I've just never used it. If so, you can check and see if it's installed. I have no idea if we installed that widget. But if I had to guess, there's almost certainly some widgets that make some of this easier. Yeah, what do you know? Jupyter Lab GitHub. I don't know what that is, but it's installed. Like I said earlier, there's tools like GitKraken and GitHub Desktop. Oftentimes they can be very convenient tools because they visualize these commits and changes and stuff a little bit more nicely. When you're using the command line, I mean, you kind of got to know what you're doing because the information you get it is all the information. It's just very dense and kind of in a particular format. If you're not a big fan of the command line, my suggestion is to try GitHub Desktop or GitKraken. I think GitKraken is free up to some number of repositories or something like that. And I think Desktop is also free. So those tools can be pretty nice. A lot of people like them. I don't tend to use them because I learned on the original Git, but yeah. Other questions? Okay. Well, we're pretty much at time anyway, so thanks everyone. We will be around to help you with Git. I will just parting words. Everyone has trouble with Git. It's just part of the rite of passage of doing data science and working with Git. It's a complicated tool. Don't let it discourage you. It's pretty safe to use, and we're around to help. Cool. Thanks everyone.